Picture a football stadium. Not the fans in the stands. Not the players on the pitch. Just the stadium. Empty. Now fill it with people. That's roughly 80,000 human beings. At some point around 70,000 years ago, every single human being alive on Earth could have fit inside that stadium. Hold. Not the world. Not a continent. Not a country. Every human being. Scientists call it the population bottleneck. And what it means is this: you meet every person you have ever met, every person who ever built a pyramid or wrote a symphony or started a war. We are all descended from a group so small, so precarious, that they nearly vanished entirely. This is the story of the day humanity almost didn't make it. So, how do we know any of this? We weren't there. There are no written records. No photographs. No first-hand accounts. The evidence is written in something far older than language. It's written in our DNA. Here's the thing about genetics that most people find genuinely surprising when they first hear it. Human beings are remarkably, almost suspiciously, similar to each other at the genetic level. We look different. We speak different languages. We come from wildly different parts of the world. But strip it back to the actual code, and we are nearly identical. Now compare that to chimpanzees. A group of chimpanzees living in a single forest in West Africa has more genetic diversity among themselves than the entire population of 8 billion humans. Read that again. One forest. More variety than our entire species. That only happens one way. At some point, the human population crashed, hard, and the tiny group of survivors who made it through passed their limited genetic variety down to everyone who came after. The question is, what caused it? To find the answer, we need to travel to Sumatra, Indonesia. And we need to travel back roughly 74,000 years. What you're looking at right now is Lake Toba. It's one of the largest and most beautiful lakes in Southeast Asia. Tourists visit it every year. People sail on it, fish in it. What most of those tourists don't fully appreciate is that they are standing inside a volcano. Not near a volcano. Inside one. Lake Toba is a caldera, the sunken remains of the largest volcanic eruption in the last 2 million years. And when it blew, approximately 74,000 years ago, it didn't just erupt. It detonated. To give you a sense of scale, the 1980 eruption of Mount St. Helens, the one that flattened an entire American forest and made the news worldwide, released roughly 1 cubic kilometer of material. Toba released somewhere between 2,500 and 3,000 cubic kilometers. It blanketed South Asia in ash up to 15 centimeters deep. In some places, the ash layer was 6 meters thick. And then came what scientists call a volcanic winter. The ash and sulfur particles ejected into the upper atmosphere blocked sunlight across the entire planet. Average global temperatures may have dropped by somewhere between 3 and 5 degrees Celsius. In some regions, possibly much more. For years, plant life collapsed. Animals that depended on plants collapsed. And the small, scattered groups of early humans scattered across Africa and Asia, already living on the edge, faced conditions unlike anything their species had ever encountered. I want to pause here and ask you to do something. Stop thinking about this as a historical event. Stop thinking about data and timelines and geological epochs. Think about a person, a woman, let's say, standing on the southern coast of what we now call South Africa. She's cold, colder than anything her people have experienced in living memory. The sky is a strange color. The ash falls intermittently like gray snow. The forests inland have thinned. The herds have moved or disappeared. But here, on this coast, there is something. Shellfish. Clinging to the rocks at low tide. Not glamorous. Not the hunting stories that get passed around the fire. But consistent. Reliable. Enough. Archaeological sites like Pinnacle Point on the South African coast show exactly this. Evidence of early humans subsisting heavily on coastal resources right around the time of the Toba eruption. It is the most plausible picture we have of what human survival looked like in this period. Small bands. Coastlines. Shellfish and tide pools. Clinging on. The genetic models suggest the breeding population. The number of adults actually reproducing successfully may have dropped as low as 1,000 individuals. Some estimates say even fewer. 1,000 people. That is not a civilization. That is barely a village. And from that village, impossibly stubbornly, came everyone. Now, here is where it gets interesting. Because I've just told you a very clean story. Volcano erupts. Humans almost die. Small group survives on coast of Africa. Everyone today descends from them. And that story is probably mostly right. But science is rarely that clean. And there are researchers, serious, credentialed researchers, who think the Toba bottleneck theory has been oversold. Here's their evidence: archaeological sites in India. At a site called Jwalapuram in southern India, researchers found stone tools both below the Toba ash layer, meaning before the eruption, and above it, meaning after. Same style. Continuous occupation. If Toba had been as catastrophic as the bottleneck theory requires, you would not expect to find humans simply carrying on in India. But there they are. There are similar questions raised by sites in southern Africa, where the archaeological record doesn't show the kind of sudden collapse you'd expect from a near-extinction event. So what do we do with this? The honest answer is, we don't fully know yet. What most geneticists still agree on is that the bottleneck happened. The DNA doesn't lie about that. Whether Toba caused it, triggered it, or was simply one pressure among many is still genuinely debated. And I think that is the most interesting part of this story. Not that we have all the answers, but that the question is still alive, still being argued over, still unresolved. 70,000 years later, we're still trying to figure out how we survived. B-roll, cave paintings, early human artifacts, fire. Here's a question I find endlessly fascinating. What if the bottleneck didn't just nearly destroy us? What if it also shaped us? Think about what a small, isolated population under extreme pressure actually requires to survive. Cooperation, communication, the ability to trust strangers from your group with your life, the ability to share resources when you could, biologically speaking, hoard them. Some researchers argue that the extreme social pressure of the bottleneck period may have accelerated exactly these traits, the ones that make humans so unusual among animals. Our capacity for language, our almost compulsive need to form groups and tell stories and establish shared beliefs. We didn't just survive the bottleneck. We may have been forged by it. The people who made it through were, almost by definition, the ones who were best at working together, reading each other, holding a group of frightened people together under a gray, ashen sky. Every human alive today is descended from those people. That is worth sitting with. Let me zoom out one final time. Because of the bottleneck, human genetic diversity is astonishingly narrow. Two humans chosen at random from opposite ends of the planet are more closely related than two chimpanzees from the same forest. That means the distance between you and any stranger you pass on the street, regardless of where they're from, what language they speak, what they look like, is almost nothing measured in genetic terms. We are all of us cousins. Not metaphorically, mathematically. Now here's what I keep coming back to. That small group on the South African coast 70,000 years ago, they had no idea. They were cold and scared and hungry, and they were trying to get through the next day. They had no way of knowing that they were it. That every thread of human history, every empire and discovery and artwork ran through them. They just survived. And then they had children. And somehow, improbably, impossibly, here we all are. I want to leave you with one question. And I mean this genuinely. I don't have an answer to it. If that small group hadn't made it, if the ash had been a little thicker, the winter a little longer, the shellfish a little harder to find, would something else have eventually evolved to take our place? Would some other branch of the primate family have gotten there eventually? Would the planet have simply carried on without anything like us? Or was this, right here, right now, all of this genuinely a near miss? I think about that more than I probably should. If you do too, I'd love to know what you think. Drop it in the comments. And if you want to go deeper on any of this, the Toba debate, the genetics, the South African sites, I'll link the best sources in the description. See you in the next one.